Hello, Algebra 2 students. This is a Regent review on Unit 8, which covers both polynomials, functions, and rational functions. So it says algebraically determine the zeros of this function. We have an even number of terms, so we're going to use factoring by grouping. Group the first pair and the last pair here. You would group all pairs. You can't just magically get multiplication, so you have to include that addition sign. Factor out the GCF. In this case, it would be 3x squared. And what you would be left with would be x plus 4. The greatest common factor in the next group would be -3. You'd get x plus 4. Now the greatest common factor between those two groups and those two terms are x plus 4. So when you pull that out, the things that are left are 3x squared minus 3. Pull out the greatest common factor now, which is 3. Okay, now you have a difference of perfect square. Difference of perfect square leads to the conjugate, so you're going to have the same terms, just different signs. Square root of x squared is x. Square root of 1, 1. A 0 is when these equal 0. So if any of those multiplicative factors equals 0, the whole thing equals 0. So I'll show the work with one of them. You subtract 4 and you get x equals -4. In this case, you know this would be -1. In this case, you know this would be +1. So the zeros are -4, -1, +1. Okay. For this graph, we have zeros at -c. So this would be x plus c, the factor. At -b, so that factor would be x plus b. And at +a, so that would be x minus a. So a lot of students might fall for this trick that x minus a, x plus b, x c, right? But think about it. What degree of a polynomial would this be? X times x times x. That would be x to the third. Is this a cubic? Does it look like that on the graph? No. This is a quartic function, right? Quartic functions typically look like this. So there are 3 zeros, but one of them does not penetrate the x-axis. One of them does not go through the x-axis. It bounces off, which, if you remember, that means that it has an even multiplicity. Right? Multiplicity just means how many times a factor occurs in the equation. So if we already have 3 degrees and we know that this is a 4th degree polynomial, we're going to have one more of that factor. So we have x plus c squared, x minus a, and x plus b. Your answer would be 4. Okay. Polynomial equation of degree 3. P of x is used to model the volume of a rectangular box. The graph of p of x has x-intercepts at -2, 10, and 14. Which statements regarding p of x could be true? So -2 would be x plus 2. So we know it's not going to be this one because that's x minus 2. +10, x minus 10. 14, x minus 14. B is correct. That could be the equation of p of x. Now to find the maximum volume that occurs, to find the maximum volume, right, we're going to put this equation into our calculator. graph it. I'm really not seeing much when I graph it, so I'm going to go to zoom, zoom fit. I could see much more, but I'm going to zoom out a little bit because I don't really see enough. So I press zoom, zoom out, press enter. Okay, and I can see that maximum now. So I'm going to do second trace maximum. I'm going to go to the left of the maximum, to the right of the maximum, press enter one more time, and I get the maximum is x equals 12.140735, y equals 56.282864. So the maximum does not occur at x equals 10, so C is incorrect, but the maximum volume is approximately 56. So that's correct, B and D. Okay. For this question, x minus a, we know it's going to be at a, x minus b, so there'll be a 0 at b, x plus c, that's going to be at negative c. So we have c, negative c. We're going to have a and b, but it says a is greater than b. So I'm going to put b first because it's less than a. A will be next. Okay, and there's a positive y-intercept of d. Okay. So now we basically did everything that we have to figure out. Now, the leading coefficient, it looks like it's going to be positive. There's no negative in front, right? And x times x times x is x to the third. So the first term would be x to the third. We know positive x to the third looks like this. If it was negative, it would look like this. So you're going to go through, around, through, and back around. And that would be p of x. Okay? So now, for 5, it says determine for which polynomials x plus 2 is a factor. So you could do polynomial long division. You could do synthetic division, right? You're allowed to do synthetic because the divisor has a leading coefficient of 1 and the highest degree of 1. Or the easiest thing you could do is the remainder theorem. The remainder theorem, you set your divisor equal to 0 and solve, almost like you're doing a synthetic division problem, and then you just have to plug in. So we're going to plug in negative 2, p of negative 2, q of negative 2, okay, put that in your calculator. I end up getting 60, so the remainder is 60. So 60 is not equal to 0. So if it has a remainder that exists, then that means it's not a factor. So x plus 2 is not a factor or is not a divisor of p of x. Now let's check this one. Negative 2 to the third minus 3 times negative 2 to the second minus 16 times negative 2 minus 12. You end up getting 0. 0 does equal 0, which indicates that x plus 2 is a divisor, or, ooh, I put not, is a divisor of q of x. Okay? Now we have polynomial identity. It says algebraically prove that this equals this. So, to prove this, what you're going to have to do is prove the left side equals the right side. So, in order to combine two fractions, you have to have a common denominator. So, 1 is the same as saying x to the third plus 8 divided by x to the third plus 8. So, x to the third plus 9 over x to the third plus 8 equals x to the third plus 8 over x to the third plus 8 plus 1 over x to the third plus 8. You could combine your numerators now because you have a common denominator. And look at that, they're the same. We just proved it algebraically. Okay. The function is undefined when x equals. You know a number is undefined when you have a denominator of 0. You cannot divide by 0. It doesn't make sense. So, your denominator can't equal 0. X squared plus 2x minus 8 equals 0, or we could say not equal to 0 if you want. There is a negative on the product term, which indicates different signs. So x minus, x plus. What factors of 8 would subtract to 2? 4 and 2. It's a positive 2, so it would be negative 2, positive 4. Alright, 4 minus 2 would be positive 2. So, you set those factors equal to 0, and you would get negative 4 and positive 2. So the function would be undefined at negative 4 and positive 2. Okay. Now we have an expression with negative exponents. First operation I see is division, and you have a common base, so you use your quotient law. You would subtract exponents. So 17 over 8 minus 5 over 4. Seven over 8. Now you have an exponent within an exponent, so you could multiply exponents. Negative 4 divided by 8 would be negative 1/2, so it would be 7 over 2. Y to the negative 7 over 2 equals y to the n. And then you have a common base, so n equals negative 7 over 2. So if you wanted to give a little explanation, you can. You could say this is the quotient law that we use. Then we use the power law. And then we use the method of common bases. Okay. The expression is equivalent to. It looks like there is the last term is divided by the divisor, so you know that's usually what you do with a remainder. So we could use division to find the quotient, right? And in order to do so, let's see, can we do synthetic division? No, right? Because the leading coefficient of the divisor is 3, not 1. So we're going to have to use polynomial long division. Okay, it looks like we have our quadratic term, we have our constant term, right? So degree 2, degree 0, but we're missing our linear term, we're missing our degree 1 term. So we have to include a placeholder 0. Three x goes into 9x squared. 3x times 3x, 9x squared. 1 times 3x, 3x. Subtract that whole term. First term always cancels out. You get negative 3x. 3x goes into negative 3x. Negative 1 times. Negative 1 times 3x is negative 3x. 1 times negative 1, negative 1. Bring down the negative 2. Subtract. First term cancels out. Negative 2 minus negative 1 is negative 1. So that's your remainder. So you always put your remainder over your divisor. So 3x minus 1 over 3x plus 1. Let's say you really couldn't do this, right? Something you could do. Plug in a value for x, some random value. You could say x equals 7. And then plug in 7 into your options and see which ones would give you the same answer. Okay? For this question, this is kind of an odd one. There's really no purpose to doing it, but it's just to show that you can manipulate, algebraic expressions. So, how do I get 1 from 2, right? That's the same as saying 1 plus 1, right? 2. And then it looks like they just combined these two. So, we need a common denominator. To change 1 to have a denominator of x plus 2, it would be x plus 2 over x plus 2. You could combine combine your numerators, because you have a common denominator, but remember, you're subtracting this whole expression. So, 1 plus x minus x would cancel out. 2 minus negative 1 would be 3. So you have 1 plus 3 over x plus 2. And that's your answer. Okay. A rush hour commuter train has arrived on time 64 of its first 80 days. So 64 of its first 80 days it arrived on time. As arrivals continue, which equation can be used to find x, the number of consecutive days that the train must arrive on time, on schedule, to raise its on-time performance to 90%. So we want it to raise to 90%, which is just 90 over 100. 64 of its first, so it arrived on time. So 64 represents how many times it's arriving on time, right? So we want to increase that amount by however many days it could arrive on time, and the number of consecutive days that the train must arrive on schedule. So you're increasing the number of days and increasing the number of times that it arrives on time. So 64 plus x over 80 plus x equals 90 over 100. That's more of a logic question. Okay. What is the solution set of the equation? So now we're doing rational equations. Rational equations, you basically want to get rid of your denominators. So just multiply by every denominator that you have on both sides. Okay. Make sure you distribute to both terms. So when I distribute here, what would cancel out? It looks like the x would cancel out. So you'd be left with the 2, and you'd be left with the x plus 3. Okay? When you distribute... Oh, what happened? Okay. When you distribute here, you would be... The x plus 3 would cancel out, so you'd be left with 3x, and you'd be left with x. And in this case, the x plus 3 would cancel out, so you'd be left with x, and you'd be left with x. So we could distribute those out. 2x plus 6 minus 3x squared equals x squared. We have a quadratic. You want that to equal 0. So I'm going to add 3x squared, subtract 2x, and subtract 6. Okay? You could use quadratic formula. You could try to factor this. Let's try to factor it. I wanna see if we could factor it. So factor out your GCF first. 2x squared minus x minus 3. And now we could check if we could use AC method, right? Remember, if you're using AC method, you have to factor out the GCF first. So x squared minus x minus 6. Factor the new trinomial, so different signs. What factors of 6 subtract 2, -1, 3, and 2? Remember to pay back what you borrowed. Borrow, pay back, AC method, same thing. So divide by that 2. Simplify all rational expressions. And then any remaining denominator goes to the leading coefficient of its binomial. Just remember that 2 from the beginning. So now we factored, right? And to find the solutions, we would have 2x minus 3 equals 0. Add 3. Divide 2. So you get 3 over 2. And you also have -1. So our two solutions are -1 and 3 over 2. But are we done? No, we are not done, right? We have to look for extraneous solutions. Remember, radical and rational expressions are the two solutions you must check for extraneous solutions. It's rational if the function's a fraction. It's radical if it has a radical in it. So, rational expressions are a little bit easier to just see right away if they're extraneous or not, right? What would make this, remember, it's undefined if, when you plug it in, the denominator equals 0. So, this denominator here, what would make that denominator equal 0? What x? X would have to equal 0. Is that one of our solutions? No. So we don't have to worry about that one. What about this denominator here? When let's say we set that denominator equal to 0, what would x equal in order to be 0? That denominator, the x cannot equal -3. Is that one of our solutions? No. So, both of our solutions are real solutions to this expression. Okay. And then the last question here. First, factor anything that could be factored, right? So we have a plus sign, so same signs, both are going to be negative. So 4 over k minus, and now, what factors of 12 would add to 8? 6 and 2. So, remember what we said before. You want to multiply both sides by every denominator. Okay? We're going to distribute that out. So, on the left-hand side, both would cancel out, so you'd be left with 4. On this term here, k minus 2 would cancel out, so you'd be left with k times k minus 6. On this term here, k minus 6 would cancel out, and you'd be left with 1 and k minus 2. So, we're going to simplify this. You could subtract 4 on both sides, combine like terms. K minus 6k would be negative 5k. Negative 2 minus 4 would be negative 6. We could probably factor this, otherwise you'd have to use quadratic formula. There's a negative sign, so it means different signs. K minus k plus, with factors of 6 would subtract to negative 5. It would be 1 and 6, right? So negative 6, positive 1, because we want it to be negative 5. And your two zeros would be negative 1 and positive 6. Is that our solutions? Are we done? No. Remember, you must check for extraneous solutions with radical and rational equations. So, this factor here, what solution would make that factor equal 0? It would be 6, right? Where k equals 6. Is that one of our solutions? Yes. So, we're going to cross that out, and we're going to write extraneous. Now for k minus 2, what would make that extraneous? Be k equals 2. Is that one of our solutions? No. And that was the only factors we had in the denominators, so our answer would be k equals negative 1. Okay, hopefully this helped. Thank you.